Hello everyone, today we're going to be talking about question number 5 on the 2024 AP Calculus FRQ. This is just the AB portion, it is not the BC portion. It focuses on implicit differentiation and a little bit of related rates at the end. And this is a non-calculator question. Alright, so let's get started on this problem. Alright, so here we go. Let's talk about this question number 5. So, considering the curve defined by this equation, x squared plus 3y plus 2y squared is equal to 48, all right, it could be shown that dy over dx is equal to negative 2x plus 4y. So on this FRQ, we're going to be doing a couple different things with implicit differentiation. The first one is we're doing, hey, let's use tangent approximation. The second one is let's do horizontal tangent lines and dealing with that. Then part C, we're talking about vertical tangent lines, and then the fourth one we're talking about like related rates and differentiating with respect to time. So let's get crack-a-lackin'. Let's do part A. So there is a point on the curve near 2, 4, with the x-coordinate is 3. Use the tangent line at curve 2, 4 to approximate the new y-coordinates. All right, so they tell us exactly what to do. You create a tangent line. So let's create a tangent line at 2, 4. So if we need an x, we need a y, and we need an m to create this y minus y1 is equal to m x minus x1 line, and that's going to create that tangent line approximation. All right, so our x value is going to be 2, our y value is going to be 4, and our slope at this point is just going to be, hey, we just got to plug in. So let's plug in dy over dx. So we are going to do negative 2, 2 over that 3 plus 4 times our y, which is 4. We then get negative 4 over 3 plus 4 times 4, that is going to be 19. So our slope at this point for this line is going to be negative 4 over 19. So let's do this. We're going to be plugging these values into y1, x, and x1. So we have y minus 4 is equal to negative 4 over 19, x minus 2. All right, so that is our tangent line at 2, 4, and so now we're going to use that to approximate. First, I'm going to bring that 4 over, though, so just some arithmetic, add that 4 over, so we have negative 4 over 19 times x minus 2 plus 4. All right, so let's use our coordinate 3, our x value coordinate 3 to plug in. So we have y is equal to negative 4 over 19 times 3 minus 2 plus that 4. Okay, so 3 minus 2, that is 1. So we are just left with negative 4 times over 19 times 1, which is going to be negative 4 over 19 plus 4. Get like denominators in this case, so that will be y is equal to negative 4 over 19 plus 19. What is 19 times 4? That will be 36, so it will be 76. Add that 76 and then negative 4 together, and we get that 72 over 19 as our final answer. And that is our approximation of this y value. All right, let's go on to problem B. So they're saying, hey, is the horizontal line y is equal to 1 tangent to the curve? Give a reason for your answer. Okay, so right here, horizontal line, tangent to our curve. We know that if that is true, the dy over dx at this point has to be equal to 0. That's what we need to know, that dy over dx has to be equal to 0 for it to be horizontal. So let's say, hey, let's say y is equal to 1. Let's figure out what point that correlates to with x on our curve. So how we're going to do that, we're going to be plugging in y is equal to 1 into our curve. So we have x squared plus 3 times 1 plus 2 times 1 squared is equal to 48. All right, let's solve this. So we have x squared plus 3 plus 2 is equal to 48. we get x squared plus 5 is equal to 48. And then we get x squared is equal to 43. Let's take the square root. We get x is equal to positive or negative square root of 43. So our two possible points where this could happen when y is equal to 1 on our curve are going to be square root 43, comma 1 and negative square root 43, comma 1. So let's plug those points into our derivative to see, hey, do we get this desired dy over dx is equal to 0? That's the question. So dy over dx at square root 43, comma 1, that is equal to negative 2 square root 43 times square root 43 over 3 plus 4 times 1. That is negative 2 square root 43 over 7. Notice that is not equal to 0. Okay, let's try that dy over dx at our other value. Negative 2 times negative square root 43 over 3 plus 4 times 1 again. In this case, we're going to get positive square root 43 over 7, which is also not equal to 0. So it's not possible, right? The tangent line at this point is not going to be horizontal. So at the point when y is equal to 1, and that is square root 43, comma 1, and negative square root 43, comma 1, our dy dx is not equal to 0. Thus, the tangent line at these points are not horizontal. Therefore, or thus again, the line y is equal to 1 is not tangent to our curve. All right, let's go on to part C. So here it says the curve intersects the x-axis at the point square root 48, comma 0. Is the line tangent to the curve at this point vertical? All right, so same kind of idea here. It's just now we're not dealing with horizontal, we're doing vertical lines. A vertical tangent line, a vertical line has a slope, or a dy dx, or slope, is equal to an undefined number. So if we do, hey, dy over dx at this square root 48, comma 0, if we plug in and get an undefined number, aka 0 in the denominator, we got a vertical tangent line. If we don't, therefore, we don't have a vertical tangent line at this point. So let's plug in. So we have negative 2, comma square root 48 over 3 plus 4 times 0. That will give us negative 2 square root 48 over 3. That is not undefined. So at square root 48, comma 0, our slope is defined. Or is a real number. I'm going to say is defined. Therefore, the tangent line is not vertical. Beautiful. All right, let's go to this last problem here. All right, for a time greater or equal to 0, a particle is moving along another curve by the equation y to the third plus 2xy is equal to 24. At the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x-coordinate of the position, a particle's position with respect to time? All right, right here, we got to think, hey, we're talking about a time at an instant. This is going to be the derivative of something with respect to time. Okay, we are only given x and y, so we have to be talking about dx over dt. We're going to have to be talking about dy over dt. And we're also going to have to be talking about x and y. All right, let's start with x and y. They give us a point at this time that is going to be 4, 2. So our x is going to be 4, our y is going to be 2. We are also given the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. So our rate is going to be 2. Since it's decreasing, it is going to be negative. And we want to figure out dx over dt. We want to figure out how quickly or what the rate the particle's position is changing with the x position is changing. So let's start off with our derivative, our equation. That's y to the third plus 2xy is equal to 24. And we need to throw dx dt, dy dt in here, so we need to take the derivative of this equation with respect to time. So let's do that. Y to the third, the derivative of that is 3y squared. Remember, we're taking derivative with respect to time, so we need to notate dy over dt. And then we're doing plus, okay, we have 2xy. That is going to be a product rule because we have multiplying. Our first function is going to be that 2x. Our second function is going to be that y. So we need to do, hey, the derivative of the first, so the derivative 2x, that is going to be 2. Don't forget dx over dt. Times our second function, which is just going to be y, plus our original function of the left side, which would be 2x, times the derivative of y, which would be dy over dt. And that's all equal to the derivative of 24, which is 0. All right, now let's check and plug in. So we have 3y squared. Let's plug in, so that will be 3y is going to be 2 squared times dy over dt, which is negative 2, plus 2 times dx over dt. We do not have that number, so I'm going to keep that as dx over dt, times y, which is going to be r2 again, and then plus 2 times rx, which is 4, times dy over dt, which is negative 2, and that's all equal to a whopping 0. All right, 3 times 2 squared times negative 2. 2 squared is 4. 3 times 4 is 12. 12 times negative 2 is negative 24. 2 times dx over dt times 2, that is just gives us 4 dx dt. And then 2 times 4 times 2, negative 2 to be exact. 2 times 4 times negative 2, that will give us negative 16. Therefore, negative 24 minus 16, that's going to give us negative 40, plus 4 dx dt equal to 0. We get 4 dx dt is equal to 40. Dx dt is equal to 10. And that is all for this FRQ. Let's now talk about how the AP graders graded this FRQ. Okay, so for problem 1, they first gave a point if you correctly got the correct slope. So if you got negative 4 over 19, you got 1 point. Then if you got the correct approximation all the way down here, that's 72 over 19, you also got a point. And that was it for that first question, part A. All right, so for part B, you got a point if you knew to say, hey, dy over dx has to be equal to 0 in this case. You got a point for that. And then you got 1 point for your answer and your reasoning. And being able to back that up, you got another point. For part C, you just got 1 point for your answer and your reasoning. You didn't get any extra points for saying it was undefined or anything, but you did get 1 point for everything for answering the question. And then lastly, this is where a lot of the points came from in this problem. Okay, so the first part, if you attempted the implicit differentiation, aka you attempted this step with respect to t, you got 1 point. If you actually got the derivative, you got another point. If you correctly got the derivative with respect to t, you got another point. If you've realized, hey, I need to use -2 for dy over dt, they gave you a point also. And lastly, if you got dx over dt is equal to 10, you got 1 point. And that is all 9 points allocated for this FRQ. And just like that, this FRQ is done. This was question number 5 on the 2024 FRQ for AB. It was pretty simple. It was a lot of implicit differentiation, handling tangent lines, horizontal, vertical, and then a little bit of related rates at the end. I hope you found this video helpful. Comment down if you did, and I hope you are doing good studying for AP test. More videos to come. I hope you enjoy my channel, and have a great day.